Hi, my name is David, and I work with GoEngineer on the 3D scanning team. Today we're going to look at a software called Geomagic Design X, which is our premier reverse engineering tool that works with 3D scan data. This propeller was scanned with a Creaform HandyScan 700 scanner, and you can see here, if I zoom up close enough and I'll turn the wireframe of the triangles on, that the mesh is composed of a bunch of triangles. This is known as an STL Mesh, and we use the software basically to model around the data. So in some sense this is kind of could be considered as like a 3D template. I'm also going to point out during the demonstration some of the unique tools that the software has to help expedite the modeling process and also show the typical workflow for sketching. I'm going to go ahead and turn off the wireframe. And also point out here, if I go to a front view, that the part is not in any coordinate system. So we need to establish a coordinate system before we start the modeling process. So I'm going to show some tools here to help us do that. I'm going to point out this concept called the region group. I'm in the region tab here, and I'm going to go ahead and turn on the regions groups that I've done so far. As you can see now, we can see some color on the part. This yellow area, this pink area here in the end, and underneath we've got this green region. These regions can help us establish reference geometry, can help us create surfaces, and can also help us create an alignment. And also you can see here as I hover over, in this case the yellow region, it sees this region as a cone. So that's very beneficial to me if I need to find the axis of the cone, or again to create a solid or surface based on this region. This one out here is a cylinder, and the one underneath here is also a cone. So I'm going to go ahead and create one more region to help us create a coordinate system. So I'm going to go normal to the model here, looking normal to it. And I'm going to use a certain selection tool. These are my selection tools I have here. I'm going to use this circular selection tool, and I'm going to place my cursor in the center and just kind of drag outward. And I'm looking to catch the top flat area of that hub. And I'll go ahead and do this again, and this time I'm going to remove the inner selection. And what I'm looking for is just kind of a ring around that flat surface. So I'm going to say Insert. And I'm going to verify by coming back over and touching that region to confirm that it sees that as a plane. So now I can create a mesh sketch based on this plane. And when I do that, you can see it's kind of virtually cutting through right at the top surface there. So what I'm looking to do is drag this arrow into the part a bit, and I can see that there's a circular profile that I can see, and that's going to help me establish the center of the part. And there's also a feature down here that I want to help when I clock the part for the x-axis. So I want to take another section, and I'll go ahead and drag that arrow further down into the part until I can see that feature I just pointed out. That looks good. So I'll say OK. At this point I can turn off my mesh, and I can see that these represent polylines in the software, and while they're useful we can snap to them. So for example, if I go ahead and create a circle and I have the fit polyline method turned on, as I touch what it perceives to be an arc or a circle, it will fit a circle to my selection. So I can go ahead and easily create a circle just by double clicking on that. And next I'm going to create a couple of lines. So I'll zoom up a bit, and I'm going to create a line. Again, polyline is turned on, so I can click here to create my line. And my next line is going to be referenced from the center of the circle, and I'm going to touch the other line so I get my preview turned on, so I can create a line that's parallel to that first line. At this point I'm pretty much done sketching with this particular sketch. In fact, I don't need my first two entities anymore. So I'm going to delete them out of the sketch, and I can exit the sketch now at this point. I'm going to turn my mesh back on. And now I have enough geometry to help me create my alignment. I'm going to come over here and come to the alignment tab and use the interactive alignment method. And it pre-selects the data for me, so I can just say next stage. And what it's looking for here is a plane. It's going to establish essentially my XY plane. And I'm going to go ahead and pick this region here as my base plane. You can see now the Z axis is going into the part. If I want to flip that where the Z axis is going outside the part, I can just hit this flip button here. So now the Z axis is going outside. And next it's looking for a vector, and that's represented here by this line. And now you can see that the x-axis is collinear with that line. And lastly, I just need to pick the origin or the endpoint of this line. And now you can see that the origin is in the middle of the part. So I'll say OK to that. And then I can confirm that here just by going to the front view. And you can tell that I'm looking straight down the part. I'm going to go ahead and delete this first sketch since it's not associative and I don't need it anymore. And I'll go ahead and turn on my system planes. So the first feature I'm going to model is this inner hub here, and that's going to be a revolution, so it's going to be a rotational sketch. So I'll need to create a vector first, and I'm going to use the two plane intersection method. So I've got a vector going right through the middle. Next, I'm going to go ahead and create what's called a mesh sketch. A mesh sketch is a two-dimensional sketch, but it's referencing the mesh. So we have two options here. One is a planar method, and the other is a rotational method. So I mentioned that this is going to be a revolution, so I'm going to go ahead and pick that method. My axis is going to be the vector 1. My base plane is going to be the top plane here. And you can tell right now it's kind of creating this cross-section right through the middle of that part. Unfortunately, at this location, it's just not the right location. So I have this ring here that allows me to rotate that cross-section, if you will, to a place that makes more sense. I'm trying to get the side of that hub in my sketch. So I'm going to change this to 35 degrees, and this is going to be basically projected, or rotated and projected back to my base plane. So I'll go ahead and accept that. And it's going to put me normal to my sketch. And again, I've got these pink polylines here to work with. I'm going to turn off my mesh for a second. So I just need to draw this, and I'm going to go ahead and draw that with a series of lines and arcs. So I'm going to pick my line tool. I'm going to turn off that polyline, and as I'm clicking and drawing, you can see that I'm building in both horizontal and vertical constraints as I draw. If I picked the fit polyline method, I would have to do that after the fact, so it's just a little bit faster to do it this way. So I'm drawing these lines here, and of course I'll go ahead and trim these up after the fact. And these small fillets I'm just going to do in three-dimensional, using a three-dimensional fillet. So this looks like a line here. Okay, so that looks like I have enough lines. I will do one more for construction. That'll be my center line, if you will, to rotate about. And now I'm ready to trim these things up, and I'll go ahead and do that right now. So I'm going to use a corner trim, and I'm going to go ahead and just walk around trimming these lines together. And I will need to add a couple of fillets, as I mentioned. We'll do that after I get done trimming. Okay. And that's small enough, so I'll trim that as well. Now I have two larger radiuses here that I can draw. So I'll go ahead and use the fillet function, and I'm going to go ahead and zoom up a bit. This is kind of a dynamic way to do it, so I'm going to click one entity, shift and hold the second one, and now I can click and drag the radius I want visually, and it's going to put a dimension on it automatically that I can edit if I want to. Okay. The other thing I'm going to point out here is as we're drawing, we have the ability to check our sketch versus the cross-section that we set up. So for example, if I come over here to the accuracy analyzer, I can say show the deviation, and of course you can see at the top here I on purpose drew this square, but the point is that you get these whiskers that correlate to the color map, and as I hover over them you can get a readout of the value of the deviation. This can come in handy, obviously. So I'm done with this sketch, so I'm going to go ahead and exit the sketch. And the first thing I'm going to do is do a revolve. So I'm going to right mouse click on the screen and do a solid revolve. And it is correct from the get-go. It's going to rotate it 360 degrees. And then you can see here that that is my first solid feature. And I can go ahead and turn on the mesh just to kind of look at it. So you can see that that would be my first feature, that center hub. The next thing I'm going to model are these two little features here on the back side of the part. So I'm going to go ahead and create a plane, and I'm going to pick the solid face of the solid as my reference. So I have a plane on that solid face. Now again, I'm going to create another mesh sketch, and I'm going to pull this offset arrow slightly upward so I can see a clear, clean profile of those two features. And I'll go ahead and accept that. And again, I'm going to turn off the mesh and the solid for a second. So I'm going to go ahead and start to draw this one profile here. So I'll go ahead and draw a horizontal line. And I'm going to draw a construction line because I want to ensure that the feature is in the center of the part. So I'm going to actually mirror that line over the symmetry line. The other thing I want to do is I'm going to turn the solid back on for a second. I'm going to convert both these edges here because they are the same, and it's just easier to draw that way. So I'll go ahead and turn that off for a second. Now I need to just make these a little bit longer because when I trim, I'm going to use a different kind of trim. I'm going to use a power trim, basically just picking entities I don't want this time. So it's just a matter of selecting the pieces I don't want. And now I'm ready to copy rotate this over to the other side. So I'm going to do a circular sketch pattern. My entities are going to be these four items, and it's going to be 180 degrees, so that's good. I'm going to exit out of the sketch, and I'm going to turn my mesh back on for a second. So I don't know the distance from the top of this down to the solid body. One way to do it is simply just to do a measurement. So I can quickly just measure, and I'm constraining it along the z-axis. So I'm going to say from this face up to this area here, somewhere right there. So that's 0.1184. So now that I know that, I can go ahead and extrude that and change that to that value, so 0.1184. And I'm also going to tell it to merge because we want to merge it into the main body here. Okay, so the next thing to focus on is one of the blades here. I'm going to use the one obviously that has the regions on it. So I'm going to go ahead and create a mesh sketch on the front plane. And as before, I was using this offset arrow here. You can see that as I move up and down, it gives us a value. That value is correlated over here. But because the blade is 3D, I'm not getting a full profile. I'm only getting a portion of that. So we have this other arrow that we can use called the silhouette arrow. So in conjunction with the other arrow, I can just go ahead and drag this and create somewhat of a volume, as you can see. And it's looking at, basically now it's capturing the whole 3D profile and projecting it down to 2D. So that's what we use when we have a 3D shape that we're trying to get the profile of, And again, I'm going to go ahead and crop the polylines. I don't need to see all 4. So when I'm done, I can go ahead and say OK. And now I'm normal to my sketch again. And I'm going to go ahead and turn off the mesh. Just it's easier to draw that way. So I'm going to go ahead and create this. I'm going to create these with lines and arcs. This first one here is going to be, let's say, a 3-point arc. Actually, I'll do this one first. Again, I can just double click on it. This will be, doesn't quite fit, so I'll go ahead and fix that later. And this one here, I'm going to treat this one as a line right here, but I will do a 3-point arc in this area and say OK. Now I'm going to go ahead and make some adjustments here. I'm going to go ahead and resize this arc, and then from about right there or so, I'm just going to go ahead and create a tangent arc. But before I do that, I'm going to create this as a line, and now I'm going to go ahead and create a couple of tangent arcs. One is going to be here, and the other will be here. And again, I might have to make some adjustments after I draw that. So I'll go ahead and grab this little tangency point and adjust that. And also I will draw another line from the end of that arc to the end of that arc. And now it's just a matter of trimming and maybe a couple of little slight edits here. So I'll go to the trim function. Again, we'll use the corner trim. And that looks pretty good. What I will do is go ahead and move this outward a little bit. And extend that as well into the part, just making some subtle changes. So that looks pretty good right about there. Okay, so that's my sketch for the blade, for the profile. I'll go ahead and exit out of the sketch, and I'll turn my mesh back on. And again, I'm going to do an extrusion with this, so it's going to be a solid extrude. So I'm going to go just some distance up in the positive Z, and then I'm going to say opposite direction, and just as long as I'm past the top and bottom of the blades, that should be fine. So that looks good. I'm also going to turn off the merge and go from there. So the next step is to create a few surfaces that we're going to use to trim the solid part of the blade here. I'm going to go ahead and turn off my solid for a second, and you can see here that we're going to use these regions to fit some surfaces to. And I'm going to do that underneath here, underneath the surface primitive function. And we're looking to extract a cone here. So I'm going to tell it to specifically extract a cone. And I'm going to select that region. Maybe I want to get a preview of it. And then I'll say OK. So that's our first surface. I'm going to do the same thing for the underside here. Extract a surface for the bottom, and then here at the end, we can go ahead and turn these two surfaces off for a second. I'm going to do the same thing here. Now this is a cylinder, so I'm going to go ahead and fit a cylinder to this region. Okay, so I'm going to turn on my other surfaces as well as the solid, and I might need to extend that small surface, but I'll do that after. So I'll go ahead and turn that off, and I'm going to go ahead and use this cut function. So my tool is going to be this top surface. My target body is a solid body, and then which side do I want to keep? I want to keep this piece down here, and I'm going to repeat that process with the surface on the bottom. So I'm going to select this as my tool. My target again is a solid, and I'm going to keep this thin piece here. Okay, So I'm going to turn off these two surfaces here, and I can see here that the surface needs to extend beyond the solid here. So I'm just going to go ahead and edit that quickly, and I'm just going to go ahead and make that bigger. And also I might need to edit the sketch itself. So I need to make this line a little longer on this side, and I'll exit the sketch, and now my surface is completely intersecting that solid body. So now I can trim that. And keep this piece here. So I can turn my surface off, maybe turn the mesh back on, see how it looks, and it looks pretty good. The next step will be to create a couple more surfaces to trim the blade. You can see here at the top of the blade, this kind of protrudes outward here, and you can see on the mesh that it has kind of a cutout. Same thing here on the other side. We're going to go ahead and create a couple sketches to create some surfaces to trim. So I'm going to go ahead and turn off my surface there for a second and create a mesh sketch. It's going to be a rotational method with my axis being vector 1. My base plane could be the top here, and again, it's not in a perfect spot, so I'm going to go ahead and rotate my profile. So I'm going to grab this little portion right here, so you can see that's about where it should be. And again, I'm going to crop this other side out, accept that, and I'm going to be drawing my geometry. I also want to turn my solid back on for a second because I want to reference this edge right here. So I'm going to go ahead and convert this edge to my new sketch, turn my solid off, and I'm just going to draw another line here like so. And finally, I'll just do a fillet between these two lines and fit it up against that polyline there. And I also want to shorten this line here. It doesn't need to be that long. Okay, that should be good enough. I'm going to exit my sketch, turn my solid back on, and do a revolved surface. And I don't need it to go all the way around, so I just want to locate this area here and adjust it accordingly and say OK. I'll turn that surface back on, and now I can use that surface to cut with. So I'll go ahead and cut that. It's my tool. My target body is the blade here, and I'm going to keep the bigger piece. Okay, so I'm going to repeat that step for the underside here. So again, mesh sketch, rotational method, base plane. This time I'll pick the right plane, and again I need to position that in the right spot. So I'll go ahead and grab this little ring here and put it right there. Okay, here too, I'm going to turn my solid on, and I'm going to reference this edge here. So I'm going to go ahead and convert that. Turn my solid off, and I'm going to go ahead and draw another line out here. And again, put a fillet between these two lines. And also resize this line here. And maybe this one too, a little bit. Okay. I'm going to exit the sketch and do a surface revolve. And again, I don't need to do a 360-degree revolution. So it looks good. I'll go ahead and trim this solid blade with this surface. And again, pick the bigger piece to keep. And there we go. At this point, we're ready to copy and merge the blade. So I'm going to go ahead and come up here to the circular pattern. My body is going to be the blade. The axis is going to be the vector 1. And I'm going to make 4 instances. So we have 4 blades. So now we have 5 solids in this session here. So we're going to use the Boolean function to merge them all together. So I'm going to just pick all solid bodies and merge them into one solid body. At this point, we're pretty much done. I'm just going to go ahead and turn off my surfaces here for a second and maybe check my deviation. So here we get a color map on the deviation. So basically anything that's plus or minus 4 thousandths is green. That's our current tolerance that we're within. You can see here as well that we're under here. That's because we haven't added any fillets there. So I'm going to go ahead and just add a couple of fillets and finish this part. So I'll go ahead and turn that off. And I'm going to come up here to the fillet command. I'm going to pick on this edge, and with the current value here, it's too large. We have this ability to estimate what that radius should be. So the software is going to look at that and come up with a value. We can also override that if we want to. I'm going to create another entity set here and maybe pick this edge. And again, I'll estimate what that radius should be and modify it slightly. And finally, I'll do this one more time on the undersides here of the blades. Go ahead and pick these 4 edges and use the estimate function. And it comes up with a value. I'm going to round that up to 0.19. And there you go. Thank you for watching this video of reverse engineering a propeller.